Ladies and gentlemen, in every flood-stricken region, extraction always leaves behind one thing we often overlook: materials, driftwood, sediment mud, scattered debris, all present in massive quantity at the site. Yet all of this has only been treated as a waste, while reconstruction continues to wait for supplies from the outside. Through supply chains that have themselves collapsed alongside the disaster. The worse the disaster, the more material available. Yet, the less we utilize. This condition rise to four core issues. That from the starting point of our design, the paradox of accessibility on the logistics side, extreme budget pressure on the economic side, ecological vulnerability at the side, and the passive victim syndromes that emerges and affects community. To address these four issues, we are not offering merely emergency housing, but a new reconstruction system. This system was born from the reality at the Kampung Musana Asam Aceh, a settlement standing on the banks of the Krung Koloto River. Sumatra fault data as of January 13, 2026 show that Aceh recorded the most severe level of damage compared to North Sumatra and West Sumatra. Yet disaster here did not merely damage homes, it severed the continuity of the community life. Every time a flood cycle begins, this village is always the first and the most severely affected. This idea did not emerge in a vacuum, but was born from a recurring real crisis in this village. So, how did we translate this crisis into a design identity? We named this system Reka, waving time, waving the place. This name encapsulates the core idea of our design. The post-disaster period is not merely a waiting time, but a momentum to wave life back together from the remaining materials. Debris that was considered worthless were weaved into a new structure, a house that is born from the remnants of disaster itself. So, how did we translate this philosophy into a concrete design concept? Entering the heart of our idea, building materials are not brought from outside, but woven from the remnants of the disaster itself. Drifting wood is reclaimed as the structural element. Sediment mud is processed into wall panels, and a bamboo becomes a lightweight mud wall frame that is easy to assemble and fast growing. This upcycle approach addresses both the paradox of accessibility and ecological vulnerability at once, as materials are taken from the site, not exploited from the surrounding nature. The modular and growth principle addresses extreme budget pressure by allowing units to be built incrementally, while the independent principle frees the dwelling from the demands of external infrastructure. All five converge on one core: resilient housing that does not wait to recover, but grows from its own destruction. How does this upcycle concept work technically on the actual materials? Let us dissect the process. This is the technical implementation of our upcycle concept. The process begins with sorting disaster debris into two material streams. Structurally sound driftwood is separated to become the main building frame, while the sediment mud is processed into wall panels. The wall panels themselves are arranged in a layer. A wooden frame from the outside, a bamboo frame is the holder in the middle, and the compact sediment mud as the filler material, forming a wall that is slick and strong without needing manufactured material from outside. These processed materials continually need to be supported by a system that makes dwelling truly self-sufficient. How does this dwelling meet its basic needs without relying on external infrastructure? We taste the self-sufficiency of dwelling through true basic needs: water and energy. From the roof of a Type 36 house with an average rainfall of 400 mm per month, the rainwater harvesting system is capable of producing approximately 25.154 cubic meter of water per month, 141% of the needs of 4 occupants who require only 0.6 cubic meter per day. On the energy side, 4 solar panels with a capacity of 100 watt peak generate 400 watt hours per day, far exceeding the basic need of 304 watt hours per day, leaving a surplus of 1,800 watt hours every month. This dwelling is not only stand from the remnants of disaster, but is also capable of meeting its own basic needs. If a single unit is already self-sufficient in the term of water and energy, the next question is how this dwelling can grow to meet the varying needs of different families while remaining affordable. Our modular system allows a single basic design to be adapted for various family configuration. 2 modules for individual dwelling, 3 modules for a couple, and 4 modules for a nuclear family, up to 8 modules for extended family. Growth that follow the growth of needs, not forced from the start. The construction cost of one basic unit is broken down into a frame, roof, floor, and foundation components designed to be as minimal as possible to remain affordable amid post-disaster budget pressures. Additional elements such as the eave are present in 3 functional variants: basic shade, a laundry drying area that stays drying during rain, and a vertical hydroponic box for urban farming, plus a terrace as the multifunctional space and stair as vertical circulation access, making each module not merely larger in area but also richer in the function. These modules currently do not appear out of nowhere at the disaster site. How does this debris we have been discussing actually transform into a dwelling unit installed in the field? The construction of dwelling takes place in 2 major phases. The first phase, material recovery, transform disaster debris into building asset. Driftwood is stored and reposed as structural element, while sediment mat is processed into wall panels at the local community workshop. The second phase, smart logistic, package all components into a compact flat pack kit system, maximize true load volume so that delivery remains efficient even in isolated location. The third phase is a rapid assembly. Applies a dry construction system from placing point foundation and rise floor, erecting the main structural frame to installing modular roofing and wall panels without wet cement and minimal heavy equipment, so it can be carried out directly by affected community. And this is the final result of the entire process, not merely emergency housing, but a village reborn from the ruins of its hour disaster. In the end, Estenjo remembers, this design affirms one idea: post-disaster housing does not have to wait for what does not yet exist, but can build from what is already available. Driftwood, sediment mat, and bamboo, materials that were initially considered waste, transformed into a complete frame, wall, and home. This approach does not burden the environment with new exploitation, but extend the life cycle of what already exists, turning destruction into a starting point of a new life.